It's said that nothing is harder to fake, or more fiercely guarded, than a bar of 99.99% pure gold. Behind the locked doors of America's most secretive gold refinery, ordinary rocks laced with copper and quartz are transformed, step by step, into metal so flawless that it can trigger billion-dollar trades with a single test. But if even a fraction of a percent goes wrong, fortunes and global trust could collapse overnight. How does raw earth become the ultimate guarantee of value? And why do even the world's most powerful governments fear a single impurity? This is how 99.99% pure gold is made inside the secret American gold factory. The story begins underground. Raw gold ore doesn't look like treasure. It arrives at the refinery by the truckload, packed with quartz, iron, and streaks of copper. These rocks hide microscopic flecks of gold, sometimes less than 1% by weight, locked away inside a tangled mineral web. To free it, the ore is first crushed in giant steel mills, ground down until it's nothing but fine powder. Water is added, turning the dust into a thick, muddy slurry. Now comes the chemistry. The slurry is pumped into a series of massive tanks, where sodium cyanide is introduced at carefully controlled concentrations, usually between 100 and 500 milligrams per liter. This solution forms a gold cyanide complex, dissolving the gold and pulling it out of the rock, atom by atom. Over the next 24 to 48 hours, the slurry moves from tank to tank, each stage designed to maximize recovery. Most of the gold is dissolved within the first day, but the process continues to squeeze out every last trace. Activated carbon is added next, binding to the gold molecules and separating them from the waste. Once the gold is loaded onto carbon, it's stripped out using hot caustic solution, then filtered and dried. The result is a powder or bead-like concentrate. Still rough, still mixed with silver and copper, but now 85 to 90% pure. This is as far as chemistry alone can take it. For gold to reach its final, flawless state, it must leave the world of rocks and solutions behind and enter the fire. Heat transforms gold in ways no chemical ever could. Inside the refinery, the gold-rich powder, now up to 90% pure, enters an induction furnace, where electromagnetic coils generate temperatures soaring to 1,100 degrees Celsius. This is no ordinary oven. The air shimmers and the gold concentrate liquefies into a molten pool, its surface flickering with hints of copper and silver still clinging to the mix. Operators stand behind thick shields, monitoring the process with digital thermometers and automated controls. When the temperature holds steady, the furnace tilts, releasing a stream of liquid metal into heavy steel molds. Each mold is designed to shape a bar weighing between 25 and 40 pounds, substantial, but still far from the massive ingots seen in vaults. These first bars are called d'or, a French word meaning gilded or golden. But their true value lies ahead, not in their present form. While the metal cools, a thin crust of impurities rises to the surface and is skimmed away. The bars harden from fiery orange to a muted metallic yellow, their edges rough and unfinished. Each d'or bar is immediately tagged and logged, its journey tracked from this moment onward. The tag records the batch, weight, and source mine, details that will follow the gold through every stage of its transformation. In this way, accountability is forged alongside the metal itself. What leaves this furnace is not yet market grade, but it is the essential feedstock for the next, more exacting step, the leap from rough bar to 4/9's purity. Inside the heart of the refinery, the real transformation begins. Here, Maria Jimenez, chief assayer, oversees a row of Woolwill cells, rectangular tanks lined with acid-resistant polymer, each humming with a faint electrical charge. D'or bars, still rough with silver and copper, are cut into slabs and suspended as anodes. Facing them, thin sheets of pure gold serve as cathodes. Both are lowered into a bath of chloroauric acid, held at 70 degrees Celsius and spaced just a few centimeters apart. A direct current, 2 to 3 volts, flows through each cell, dissolving gold from the anodes, atom by atom. Only the purest gold ions travel across the solution, redepositing onto the cathodes in flawless layers. Every impurity left behind, from silver to platinum, settles as a dense gray sludge at the bottom. Anode mud. This mud, far from waste, is packed with precious metals that will be recovered and refined elsewhere. After 24 to 48 hours, the cathodes are lifted out, now coated with shimmering sheets of 99.99% pure gold. No other process can guarantee this level of perfection, and only a handful of facilities worldwide can repeat it with such consistency. The result is gold that meets the highest global standards, ready for its final casting into bars the world will trust. Perfection on paper isn't enough. Every bar must prove itself in the lab. The gold sheets, now at 99.99% purity, are remelted in induction furnaces set to nearly 1,200 degrees Celsius. This final melt isn't just for looks. It ensures the metal flows without flaw and fills every corner of a precision-engineered mold. The result? A solid ingot, its weight measured to the nearest milligram, its surface smooth and unmarred. But numbers stamped on a bar are only as good as the science behind them. That's where the assayers step in. First, each bar is analyzed with X-ray fluorescence, an instant, non-destructive test that scans the bar's surface and interior for even the faintest trace of impurity. The results must fall within a razor-thin window, a tolerance of plus or minus 0.0001%. Randomly selected bars face an even older challenge, the fire assay. This method, unchanged in its essentials since the Middle Ages, subjects a sliver of gold to blazing heat in a clay cupel. The process separates pure gold from everything else, yielding a result so precise that the global market still trusts it over any machine. Only when both tests agree does the bar earn its mark, weight, fineness, and a unique serial number, ready to join the ranks of trusted assets, recognized and traded worldwide. Every gold bar that leaves the refinery carries its own fingerprint, etched by laser, a serial number as precise and permanent as the gold itself. These codes are logged in registries that span continents, matching bar to refinery, batch, and assay certificate. The packaging is no less deliberate. Tamper-evident cases, sealed under strict protocols, designed to betray the slightest interference. But even the finest packaging is only the first line of defense. The real fortress stands behind walls of steel and concrete. At the West Point Mint, Security Director Calvin Brooks oversees vault doors weighing 21 tons apiece. No single person can unlock them. Entry demands biometric scans, multiple keys, and a team of authorized staff. Each step recorded, audited, and reviewed. Inside, temperature and humidity are held steady. Each bar is non-magnetic, traceable, and subject to random checks. The world's trust in gold depends not just on purity, but on the certainty that every bar is exactly where it should be, untouched and accounted for. Every gold bar accepted on the world's largest markets must meet the good delivery standard, set by the London Bullion Market Association. That means a minimum fineness of 99.5%, exacting weight, and a pedigree stamped right into the metal. But even with these rules, counterfeiters find new ways to slip fakes into the system. In 2012, tungsten-filled bars appeared in New York, nearly matching gold's density and fooling simple scales. In 2020, thousands of suspect bars from Congo turned up with forged refinery marks and questionable origins. And in 2023, Dubai Customs seized over $60 million in gold-plated counterfeits, caught only by X-ray and ultrasonic scans. To stay ahead, refineries now test every bar with high-frequency ultrasound, log serials on international registries, and pilot digital tracking, embedding RFID chips and blockchain records. The goal is simple: make every bar traceable, every claim provable, and every ounce of trust earned, not assumed. Each year, American refineries produce thousands of gold bars, stamped 99.99% pure. Everyone tracked by serial number, verified by X-ray assay, and stored behind 21-ton steel vault doors. This process, from ore to bullion, is built on centuries of science and decades of tightening global standards, like the LBMA's Good Delivery Rules. Yet, as the 2012 tungsten bar case in New York and the $60 million seizure in Dubai showed, even the most advanced safeguards are tested by new threats. The precise methods and full security protocols inside these facilities remain classified, a reminder that what is seen is only part of the story. But the evidence is clear. Without exacting controls and constant innovation, gold's status as a foundation of trust would be at risk. In a world of digital assets and uncertainty, the enduring value of gold depends on proven purity, verified by process, not by promise.